So now I proceed to a bit more interesting part, to real examples of graph of public and real data. This is a neighborhood graph, for a relative neighborhood graph for a set of 63 aortic valve meshes. The color of labels here tells whether the mesh is healthy or diseased. The distance is optimized using the random forest in the product space, and I will come back briefly to this question. I understand that this is quite new to you, and it could be difficult to understand. But just I want to point out that the distance is optimized. It's not a Euclidean distance or point to mesh distance. And this graph represents Newman's clustering on the graph, which you can also use in the system. And the leave one out accuracy for this problem is 93%, which could not be achieved with any other technique, only with distance learning and with retrieval, with similarity search. Many people, at least in machine learning, have a prejudice against similarity search. They think that similarity search is not as accurate as, for example, using SVMs or sophisticated black box models. But I must say it is not so. If you learn a good distance, similarity search can be transparent, and it can be also powerful in terms of classification accuracy. This is on this example you can see one nearest neighborhood graph for the same problem. It's actually, it represents an easier concept, meaning that every relation here is easier to understand a little bit than in the relative neighborhood graph. For example, this arrow here means that this red colored node has the nearest neighbor as this blue node here. But as you can see, this graph is often disconnected, which makes it difficult to read it and to see the distribution in your data. This is another example, a relative neighborhood graph for lymphoma gene expression data set. And here you can see that this data set can be perfectly classified into cancerous and non-cancerous cases. One more example, which is quite similar to the previous one. The only difference is that the accuracy here is a little bit less. It's 98%. It's a relative neighborhood graph for the leukemia data set. It's also a public gene expression data set. Here you can see how expressive the neighborhood graphs are. They nicely visualize the distribution in your data. And we believe they are very good for knowledge discovery and decision support. A few more examples with real data, which are not as nice as before. This is a relative neighborhood graph for colon cancer data set. The accuracy here is less, it's 87%. And here you can see that not always the relative neighborhood graph is really so nice. Here it's a little bit more crowded. And in the case reasoner, we provide different controls to customize this graph and to make it easier to read. I will touch this question at the end of my presentation, telling you how to customize your graphs, how to play with them, so that you will do it quite easy at the end of the training. One more example where the accuracy is even worse. It's a public embryonal tumor gene expression data set. The accuracy on this data set is 80%. So this is the last example, and this example is actually different to the previous ones because one node here is not a patient, but it's a gene. And the coloring here represents different functional groups. And here you can see, you can easily see the distribution of functional groups in your data.